In this lab, we will calculate probability that a dissimilar pair with Jaccard less than or equal to 0.3 is a candidate pair. So let's do that. So I'll show you some of the calculations, some of the working. Let number of dogs equal length of Jaccard similarity matrix, and that's 3480. For dog ID in range number of dogs, and for dog ID 2 in range dog ID 1 plus 1 number of dogs. So dog ID in range number of dogs, this will be reading all the raw numbers. For dog ID 2 in range dog ID 1 plus 1 number of dogs, that will be the columns. If Jaccard similarity matrix row dog ID 1 and column dog ID 2 is less than or equal to 0.3, then print Jaccard similarity matrix row numbers dog ID 1 and column numbers dog ID 2, and that prints all the Jaccard similarity matrix value which is less than or equal to 0.3. Show working again. Let dissimilar pairs equal set empty set. So set open and close bracket. For dog ID 1 in range number of dogs. For dog ID 2 in range dog ID 1 plus 1 and up to number of dogs. If Jaccard similarity matrix row number dog ID 1, column number dog ID 2 less than or equal to 0.3, then dissimilar pairs dot add the tuple dog ID bracket dog ID 1 comma dog ID 2, and when we print the dissimilar pairs, it prints in a tuple form and surrounded by the curly braces. So these are all the dissimilar pairs. For the Jaccard similarity to be less than or equal to 0.3. So we write a definition, a function to calculate the dissimilar pairs. Definition: find dissimilar documents, and the inputs are threshold, Jaccard similarity matrix. Let number of dogs equal length of Jaccard similarity matrix. Let dissimilar pairs equal empty set. For dog ID 1 in range number of dogs. For dog ID 2 in range dog ID 1 plus 1 up to number of dogs. If Jaccard similarity matrix row number dog ID 1, column number dog ID 2 less than or equal to threshold, dissimilar pairs dot add the tuple bracket dog ID 1 comma dog ID 2 and retain dissimilar pairs. So here show working. Let dissimilar candidate count equal 0 for candidate pair in candidate pairs. So we had found the candidate pairs for the hash number of hash function equal 100 for the optimal value of bands equal 25 and the optimal number of rows in each band equal 4, which is over here. These are the candidate pairs that we found. So so let dissimilar candidate count equal 0. For candidate pair in candidate pairs, if Jaccard similarity matrix row number candidate pair 0 and column number candidate pair 1 less than or equal to 0.3, then dissimilar candidate count equal dissimilar candidate count plus 1. Print dissimilar candidate count, that is 6053. Show working. So length of dissimilar pairs. So from this definition, the dissimilar pairs where it is the Jaccard similarity is less than or equal to 0.3, the length is 5,842,761. Okay, and dissimilar candidate count we have already done, and that's 6,053, so we don't have to go through this. Now here in this function, let dissimilar documents equal find dissimilar documents. Input is threshold equals 0.3 and Jaccard similarity matrix, and the dissimilar documents are here. So it calls the function find dissimilar documents, which is this one, and the dissimilar pairs are printed here. Right. So the last part, we print the probability that a dissimilar pair with Jaccard less than or equal to 0.3 is a candidate pair. Colon, Kelly braces 0. So the calculation that we do after dot format will be put in place of Kelly braces. So dot format, dissimilar candidate count divided by length of dissimilar documents. So dissimilar candidate count, we had 6,053, and length of dissimilar pairs is 5,842,761, and when we divide those we get 0.001 and so on. So the probability that a dissimilar pair with Jaccard less than or equal to 3 is a candidate pair is 0.001 and so on.